Is a function of draw this graph y equals sine theta plus 2 sine theta. So what I'm going to do is I'm going to you put down the x values, okay, or sorry, theta, and we're going to just make a list of mainstream theta values, so to speak, okay. So mainstream theta values would be best to go too much as opposed to too little. Okay, so there's going to be a good few in here. So it's going to, I even need a few more than that. Now let's start off with 0, 30, 45, 60, 90. There we go. 90. What's after 90? 120, 135, 150, 180. Okay. Unfortunately, I'm sort of running out of space here, so I'm going to have to go underneath that again. And when I go underneath that again, I'm going to go for 210, 225. Just going to keep adding on. It's like a cycle. I just keep adding on the original values onto 180. So it's going to be underneath this one. It's going to be 210, 225. Add on 60, then 240. Add on 90 is 270. 270 is another full cycle. Add on 30, 300. 315, 330, and finally 360. Okay, I'm going to extend my graph on like this because I'm going to need a bit of room underneath it. Now, what we're going to do next is we're going to set up a table function that makes the whole thing a lot easier. So what we can do next is go to your calculator. Make sure your calculator is in degrees. Okay, so calculator. So shift setup, make sure you're in degrees, which is number 3. Okay, then go to mode table. Now the first table we're going to do is we're going to do the sin x version, if that's okay with you. So this is going to be the sin x version, and this one here underneath will be the cos x. Oh, sorry, the sin 2x version. Okay. Now, you could do it all in one fell swoop, but I want to show you what's actually going on when you're actually adding the heights of each one together, okay? So, let's go through this, and we go f of x equals sin x. Close, okay? Start at 0, end at 360. Now, see the way sometimes my gap is 15? So I'm just going to go up in gaps of 15. Alright, now I have to make sure it worked properly. Sin 30 is a half, isn't it? Well, now somebody call me out the decimal places, but I want them rounded off to 2 decimal places, okay? Are you ready? Let's go. First one? 0. Second one? 0.5. Third one? 0.71, yeah. After that? 0.87, yeah. 1. After that? 0.87, yeah. 0.71, 0.50. After keep continuing down. Just have to make sure this is sin x again. So I just couldn't fit it all in. So sin x was it? Minus 0.5. Yeah. Minus 0.71. Yeah. Minus 0.87. Yeah. Minus 0.87. Yeah. Minus 0.71. Minus 0.5. 0. Okay. Same thing for sin 2x, please. Same deal. You're going to go to your calculator. You're going to enter in sin 2x. Going to start at 0, end at 360. You're going to go up in 15ths. And you're going to take down these numbers here, okay? Everybody ready? Yeah. Okay, in red, off we go. 0. Was it? 0.87. Yeah, after that? 1. Yeah. 0.87, yeah. 0. Minus? Minus 0.87, yeah. Minus 1. Go again. Minus 0.87, yeah. 0. Then 1. Yeah. Yeah. 0.5. 0, sorry. 0, yeah. After that. Minus 0.87. Yeah. Minus 1. And? Minus 0.87, yeah. 0. Now, guys, let me describe what's happening. We have a blue function and a red function. Now look what happens when we do the composite of them, right? What I mean by the composite is, in this question we were asked to do sine theta plus sine 2 theta, okay? So you can do sine x plus sine 2x, okay? Close bracket. Same deal again. Now look what happens. I want you to relate the numbers back to what we're looking at. Okay? These numbers should always add up to the blue number plus the red number. 0 plus 0? 0. 0.5 plus... Oh, sorry, it's 30 is what we're looking at. 0.5 plus 0.87? 0.137. 0.71 plus 1? Does everybody get the gist that it's always going to be, no matter what number it is, even if we go all the way down to 300, okay? We go down to 300, because we were told to add these two functions together, it's going to be adding the two values you got together. That's, was that not minus 0.73 that time? 71?
No, it was 0.7071.
7071?
Yeah.
The same as the rest.
Oh, sorry, I'm wrong. It's 0.87 plus 0.87, which is 1 minus 1.74, which is just a decimal error more than anything. So you can see that you're constantly adding your two values together to get your new wave function, okay? So, what I'm trying to describe here now. Okay, so guys, what we're going to do now is we're going to draw this composite function here, okay, from 0 to 360. So we're going to start off by, and it's maximum and minimum value, anybody? I think it goes down to 2 at one point, up to 2 and down to 2, is it? 1.73 probably. Yeah, so 1.73 is its maximum value, so we only have to go from 2 to minus 2. So in a case like that, you can make the y-axis really big because it doesn't have to go anywhere. So then the x-axis like so. Now we'll make every 4 of them worth 1. So that's worth 1, that's worth 2. It means the bigger your diagram, the more accurate you can make it. Minus 1, and then follow that by minus 2. Now, how many blocks do I have going across? 3, 6, 9, 12, 15, 18, what's it? 21, 24, 27, 30. Alright, 30. Now, what's 30 into 360? 30 into 360? 12, right? That's not a great number. So what we'll do is we'll divide 20 into 360.
You get 18.
18, alright. Let's do that. Okay, so in a case like that, okay, guys, what you're just going to do is you're going to redraw it so it's right at the edge. Okay, so we got 2 more blocks out of that. Okay, so what we're going to do here is I'm just going to count up in, if I count up in 30s, it only takes 12 blocks to get there. Isn't that right? If I count up in 15s, it takes 24 blocks to get there. Because 360 divided by 24, anybody, is 15. Or 360 divided by 15 is 24. I have 24 blocks to use, okay? I'm going to use 24 blocks. If I use 24 blocks, that means every 2 blocks is worth 30. 30, 60, 90, what is that? 120, 150, 180, 210, 240, 270, 300, 330, and after that 360. Okay, now let's write down this composite function. So 0, 0, right?
Yeah.
Okay, next one, 30 what?
1.4.
1.4. 1.5 is there, 1.4 around there. 60? 1.7. So that's 1.75. So 1 point does barely a little bit under a 90. 1. 120. 0. 150.
Minus 0.4.
Minus 0.4. That's minus 0.5. Minus 0.4 will be just a small bit underneath it. Okay. 180.
0.
Oh, you said plus 0.4 that time, was it? Or minus 0.4?
Those ones.
And you're saying 180 is? 0. Okay. Go again.
0.4. Plus 0.4.
Plus 0.4.
Yeah.
0.25, 0.5, 0.4 about there. 240.
0.
0. Okay, go again.
What was it? 270. Minus 1.
270 is minus 1.
Yeah.
Okay, go again.
Minus 1.7.
For 300.
Yeah.
1.7, not 1.75.
Well, yeah, sorry, the same as last time. 1.7.
Okay. 330.
Minus 1.4.
Minus 1.4.
4.
1.5 there, 1.4 there, yeah. 360.
0.
0. Now look at this, guys, right? Unusual function. Comes up like this. Back down again. Now you can see that there's been interference on the height at the height. In parts it's shorter than it should be, and in other parts it's longer than it should be. Okay? Now, remember, you're on your way up here, aren't you? And you're now on your way up there. What does that mean about the
Range is 360.
sorry?
Period 360.
Period is 360. And what about the range? Well, not no. 1.732 to 1.732. So there you go. Minus 1.732 is the range to plus 1.732. Now, here's what I need you to do now, guys. What we drew here, guys, was we drew the black function. The black function is exactly as I drew it in the last part, right? Now, please remember that the black function is a contribution of the green height plus the red height. So there was a point on the graph where the green function was underneath the graph and the red function was above the graph. Therefore, the height above the graph take away the height below the graph results in the black line. Because sometimes they were negative when the other one was positive. So if you go back to your chart, sometimes you can see like this one here. You can see that it's balanced out. It's 0.87 above the graph, but the other one's 0.87 below the x-axis. This resulted in us marking a point of 0. Another case at 135 degrees would be that your sine x graph is 0.71 above the graph. However, your sine 2x is minus 1 below. This results in a minus 0.29 below the graph for your composite function, hence resulting in this fancy diagram here. Enjoy.